Alright, we've had an opportunity to explore the impulse response of the comb filter. Now let's try applying a signal from a wave file. I will use the Simple Read built-in sub-VI for this purpose. Simple Read has a number of terminals, and just take a quick tour of the terminals here. There are really only two that you need for just basic operation. I'll create a front panel control for the file path. That's how we specify the location and name of the wave file. The output is available here. Now, ultimately, I need to extract the waveform components so I can get at the one-dimensional signal array. Oh, problem here. Okay, the Simple Read produces an array. It's actually able to give us the stereo channels from the wave file. And wave files in principle can have even more than two channels. Normally, if you just need the monaural version of a wave file, you can grab the left channel, which is index 0 in the array. Since I no longer need to specify the sampling frequency myself, but I do need to specify the duration, let me convert the sampling frequency control to an indicator. I'll scoot this over to the right side where indicators normally go. That's kind of messing up my wire a lot. Let's not do that. Okay, the value or the sampling interval can be connected directly to my build waveform. And let me calculate the reciprocal of the sample time, which is sampling frequency. And now we're back to more or less where we were before. Let me take out the impulse source. And I will begin by creating an array of zeros which matches the desired duration. Then I will use replace subset to insert my sound file at the beginning of my zero-valued array. The purpose for this is that since reverberation oftentimes, especially if we have a long reverb time, will persist after the wave clip is done, we want to have an array of zeros, or sometimes people call this zero padding the audio signal, so that way we have some time for the reverberation to finish. I'd like to have the ability to listen to either the source all by itself or the source with the reverberation being applied. So my two input selector, which I like to think of as a multiplexer, or you could also call it a data selector, that will accept either the signal directly from the wave file, or it will work with the value produced by the comb filter. And this allows me to pick which of those two signals to listen to. Alright, let's take a listen to just the signal itself. I have a little speech clip here.
Rice is often served in round bowls. The juice of lemons makes fine punch.
Alright, there's some useful facts. Those are two of the many so-called Harvard sentences. Those are phonetically balanced sentences that are used for a variety of testing situations. Let's take a look at the comb filter operating.
Rice is often served in round bowls.
Let's try a longer loop time.
Rice is often served in round bowls.
So longer loop time allows us to actually start hearing the distinct echoes.
Rice is often served in round bowls.
And of course the reverb time indicates how long those echoes persist.
Rice is often served in round bowls. The juice of lemons makes fine.
You'll notice that I have the play sound check box enabled on the triple display indicator. One of the aspects of using triple display, however, we hear the sound and then the display updates after the sound is done. I'm going to go ahead and use the play waveform device, and I'll disable the triple display version of that. And this way we will hear the sound and see the graph update at the same time. This should make it a little bit easier to see these effects right away. Let's also push up the duration so we can have a longer
Rice
time.
is often served in round bowls. The juice of lemons makes fine punch.
Let's try a little bit shorter time, see what happens.
Rice is often served in round bowls. The juice of lemons makes fine punch. Rice is often served in round bowls. The juice of lemons makes fine punch.
Now that's a pretty neat sound. If you're trying to kind of make the sound of a robot, if we are trying to emulate a more of a natural sounding reverberation, that sounds really mechanical.
Rice is often served in round bowls.
Looking at the spectrum view,
Rice is often served in round bowls. Rice is often served in round bowls.
now that looks pretty much like and sounds like the original signal, just with some echoes superimposed. When we make this loop time small,
Rice is often served in round bowls.
we actually start to see almost the impression of harmonics.
Rice is often served in round bowls.
So all the streaky lines going across, that's where we see a lot of emphasis in the signal. This is actually where the comb filter gets its name, from this idea of
Rice is often served in round bowls.
these strong spikes in the frequency domain.